Okay, hey guys, how's everybody doing today? Hopefully last week you got a good start on quadratic equations. This week is three lessons on solving quadratics, and they are actually pretty tough. So I'm going to talk about them kind of quickly. Y'all might even watch this video twice, but I'm going to do the three sections, and then there's two subchapters next week. So they're not like unrealistic or anything. They're just like three pretty complicated or complex uh, topics, and we're just gonna get through them pretty quick. So before I start, let me make sure that we are on the same page as far as what does it mean to solve a quadratic equation. Okay, so here is a picture of a quadratic equation. Okay, and when I say solve it, we are looking for this and this. So solving means that it's equal to 0. So we want to find the x-intercepts. They are called the x-intercepts, the roots, the solutions, the zeros of the function. All of this is what we call these 2 points when we are solving the equation. Okay, so if I just have a quadratic equal to y, and this is not this particular quadratic, I'm just making this up, but when I have it equal to y, it's a quadratic function. Okay, y equals 2x squared plus 3x minus 5. Here's a quadratic equation. We can call it a function. When I set it equal to 0, I can now solve it and get two values for x. And those would be called the x-intercepts, the roots, the solutions, the zeros. Okay, so that's just some vocabulary. So when we were factoring so you could solve. Okay, so we are going to look at completing the square. So this is how this kind of a little analogy. I used to say if I was going to cut, I used to have a big wooden desk in my classroom. And I used to say if I was going to cut this wooden desk in half, what would I use to cut it? Would I use scissors or would I use a chainsaw? What would I use? Well, it would be really hard to use scissors. I'd probably use a chainsaw. And then I would hold up a tongue depressor and I would say, if I wanted to cut this in half, what would I use? Scissors, a chainsaw, some kind of knife. Maybe I could use scissors. So the idea is that there's the right tool for what you're doing, right? So for this, we are, when we're talking about solving a quadratic, so far we have graphing, and we have, what else have we done? Factoring. So there's different ones. This is called completing the square. We're going to look at another one, at a couple other ones. So you want to use the right solving method for what it is for the problem that you're given. So there are some problems that are going to be really easy to graph. There's going to be some harder ones that you cannot, that you have to use. We'll learn the quadratic formula. So there's other methods than this. There's two more. But you want to use the right method for the problem you're giving. So although quadratic formula always will work, it will always work. That's the one we're going to learn in a minute. Quadratic formula always works. But it's hard. It's the hardest one. So that's like using a chainsaw on a tongue depressor. It would work, but it would be hard. So you want to use the right solving method for the right problem. So for completing the square, there's going to be some specific things that we look for to use completing the square when we're solving. So let me just give you this. Y equals x squared plus 12x minus 27. Okay. Yeah. Are there factors of 27 that make 12? Let's see if we wanted to factor this. Are there factors of 27 that make 12? let's see. I picked one that we can factor. Hold on, just a second. We're gonna make this, I thought by ending with a 7. We're gonna make this 26, because that one could have factored, guys. Now let's do this. Are there factors of 26 that make 12? Okay, no, there are not. There are no factors of 26 that make 12. So completing the square is a method that we do to create, basically we're creating a factorable quadratic, okay? So first thing we do is move c, remember, because this is like ax squared plus bx plus c. So in this case, c is negative 26. We move it outside, and we, excuse me, and we add parentheses. Okay, and I'm gonna set this equal to 0 because we're gonna solve it. Okay, so we are going to do something that's called creating a perfect, let's spell that right, perfect square trinomial. Okay, so the perfect square trinomial is x squared plus 2a, hold on, I'm just going to give you an example. X squared plus 10x plus 25. Okay, so the if I take the square root of this last number and multiply it by 2, I get the first number. Let me say that again. If I take the square root of the last number and multiply it by 2, I get the square root of the first number. Okay? And the way you factor this is you just take the square root of the first term, the square root of the last term, and the first sign, whatever that is. Okay? It's just it's a pattern that you can find in factoring, and then it just always works from there. So once again, if I have something like x squared plus 20x, and I'll make this minus just so you can see, plus 100. Okay, so what's the square root of 100 is 10. What's 10 times 2? 20. So I know this is a perfect square trinomial. And then I put an x and a minus. Oh, and you put the squared. So factored, this is x plus 5 times x plus 5, or x plus 5 squared. So factored, this is x minus 10 squared, which is the same as x minus 10 times x minus 10. Okay, so this little explanation of a perfect square trinomial is what we're going to be creating when we complete the square. See, do you understand why it's called completing the square? Because we are going to give this number to make this all be true. Okay, let me go back to my problem. Oh. All of a sudden my allergies are... I'm actually in Alabama at a show this weekend. Okay, here we go. So you take the center number, b. Okay, remember, because this is b. You're always going to divide it by 2 and square it. Write this down. Divide by 2 and square. Divide by 2 and square. Every time. So, we're going to take 12, divide by 2, you get 6. Square, you get 36. So I'm going to add 36. Now, when I add 36 into an equation, I need to keep that equation balanced. So out here, I'm also going to subtract 36. Are you with me? Because I need to keep this equation balanced. So, take the square root of the first term, the first sign, square root of the last term. So now I've factored that. And then I have negative 26 and negative 36, which makes what?
Negative 62.
Negative 62. And so now I have this equation in vertex form. So my vertex would be -6, -62. You know, if we look at it in vertex form. And I can also solve it. So I can add the 62 to both sides. So 62 equals x plus 6 squared. I take the square root of both sides. So the square root of 62 equals x plus 6. And then you have to do plus or minus, because when I take the square root, it could be plus the square root of 62 or minus negative the square root of 62, and subtract 6. So my final answer is -6 plus or minus the square root of 62. So these are my two solutions. So we write them like this, but what that means is -6 plus the square root of 62, that's one x-intercept. -6 minus the square root of 62 is the other x-intercept. So those are my x-intercepts, solutions, etc. Now, I could simplify the square root of 62, but I'm just going to leave it because it doesn't really matter. But don't ever change it into a decimal. That is not done. Okay, we're going to do another one. Make sure you wrote this down, though, right here. Okay, and let's do another practice problem. Okay, y equals x squared minus 8x plus 13. Okay, are there factors of 13 that make 8? No, there are not. So we're going to complete the square. So we do x squared minus 8x, leave some space, add the 13. So we are going to come up with a new value for c. Remember, this is ax squared plus bx plus c. We want to come up with a new value for c that makes this a perfect squared trinomial. We do that by taking b, dividing it by 2, and squaring it. So what's 8 divided by 2? Yep, 4 and squared, 16. So plus 16. Now if I add 16 right here, what else do I need to do? Subtract 16. Okay, so I've added it and I've taken it away on the same side of the equation, so it's still balanced. I'm going to set this equal to 0 so we can solve. So then I take the square root of the first term, x, the first sign, the square root of the last term, 4 squared. So x minus 4 squared. So I have factored this. And when you factor it, you get x minus 4 squared. Or, okay, I think it stopped recording for a second, but, so I have x minus 4 squared, minus 3. Okay, so here it is in vertex form. I can solve it, add 3 to both sides. 3 equals x minus 4 squared. Take the square root, plus or minus the square root of 3 equals x minus 4, add 4. So the answer is 4 plus or minus the square root of 3 equals x. So this would be a great answer, realizing that you're having 4 plus the square root of x as one, plus the square root of 3, and 4 minus the square root of 3. Those are your two x-intercepts, or solutions, or roots, or zeros, or however you want to say them. Okay, so I'm going to move on to something else. You might need to go back and watch videos on this, or watch Mr. Berger do it, but this is completing the square. Sometimes we just call it CTS. Let me talk about one more thing. So this is really good when A equals 1 and B is even. So when A is 1 and B is even. Okay, so this works best for equations when A is 1 and B is even. You can use it in other ways. You can use it when B is odd. You can use it when A is not 1. There's an extra step when A is not 1. There's just a couple examples, so I'm going to let Mr. Berger show you that when A is not 1. And when b is an odd number, you just have a fraction to deal with. So when, like, let's say b is 9, okay, so 9 divided by 2 squared is 81 fourths. So leave it as a fraction. So when b is odd, leave it as a fraction. Okay, so this is best when a is 1 and b is even. Okay, okay, let's move on to the next thing. Okay, next thing is complex numbers, 5.1.5. Okay, this is a totally new concept, and we are going to just talk about it kind of briefly, and then you're just going to have to accept that it is true. Okay, so if I ask you what is the square root of 100, you would say 10. Some of you might say plus or minus 10 after that last lesson, which is correct, okay? Because 10 squared is 100, and negative 10 squared is 100. So the square root, because remember the square root is the opposite of squaring, they're inverse operations, they undo each other. So this would be the most appropriate correct answer. Now, if I ask you to tell me the square root of negative 100, meaning what number multiplied times itself will get me negative 100? Okay, what number squared? So it has to be the same number. I'll do it like that. What number squared gets me negative 100? Well, it can't be 10 or it can't be negative 10. So is there any number that squared gets me negative 100? No, there is not. So in the past, we would have said no real solution. Okay? But there is a solution, it's just not a real one. So the solution involves complex numbers. So a long time ago, in a land far, far away, when they were discovering math, they said, let's let we are going to let I squared equal negative 1. Okay, and I squared, I stands for imaginary numbers. Or, so complex numbers have an imaginary part and a real part. But in the past, you have just only been dealing with the real number system. Now we're opening up the world to another section of the number system called complex numbers. And they have imaginary parts. And when I say imaginary, I don't mean like you imagined it. I mean that that's just what we call it. So it is still real in that it's a tangible thing that we can write the answer down to, but it's called imaginary number. So I take this right here and I break this down into negative 1 times 100. Okay, which breaks down to the square root of negative 1 and the square root of 100. What is the square root of 100? 10, plus or minus 10. Okay, the square root of negative 1. Well, what is negative 1 equal to? Negative 1 is equal to I squared. So this is the same thing as the square root of I squared. What's the square root of anything squared? Itself, right? So this is I. So my final answer is plus or minus 10I. Now, it doesn't get that complicated. You don't have to do this every time. You're just going to learn that when I have a negative, my answer is going to have an I. So what's the square root of negative 25? Someone's quick. Plus or minus 5I. What's the square root of negative 49? Plus or minus 7I. Okay, so all we're doing is for accounting for this negative with I squared, which the square root of I squared is I. Okay, so the square root of 36 plus or minus 6. Square root of negative 36 plus or minus 6I. Okay, so that's complex numbers. Now, how does this have anything to do with quadratics? Well, when I have a quadratic equation that looked like this, okay, does that touch the x-intercepts or the x-axis? No. So does it look like it has any x-intercepts? No. So we would say no real solution. But guess what, guys? It still has imaginary or a complex. I'm going to say complex. complex solution. Okay, so the complex solution might be 2 plus or minus 4i. Okay, so then it would be 2 plus 4i and 2 minus 4i. That might be the complex solution. So this is not going to have a real solution, meaning it's not going to have an answer here on the x-intercepts, but it still has two solutions. They are just complex. So that is why we have this part of the number system. So let me do a problem on here. Okay. So I'm looking at this. Are there factors of 45 that make 12? No. So, oh yes, there are 15 and 3. Okay, so I can do negative, oh, but wait, let's see, but we need negative 12, and those would both have to be negative. So we cannot factor this. So let's use completing the square. So x squared minus 12x plus 45 equals 0. Okay, and this is number 11 on your homework. Okay, so I'm going to take b, divide it by 2, and square it. So 12 divided by 2 is 6, squared is 36. So add 36. If I add 36, I must also, there you go, subtract 36. Now, someone's going to say, why am I never worrying about whether it's positive or negative? And it's because when I square it, it's always going to be positive. So I don't care for that part. So b divided by 2 squared is always going to be, this is always going to be plus because I'm squaring something. Okay, so then I take the square root of the first term, the first sign, the square root of the last term. And I'm going to simplify this down here, which is plus 9. Okay, now I'm going to keep solving. So I'm going to subtract 9. Negative 9 equals x minus 6 squared. Take the square root and dun dun dun. So before complex numbers we would be done because we can't take the square root of a negative number, but now we can. Plus or minus 3i equals negative x minus 6. Okay, so I'm going to add 6 to both sides. 6 plus or minus the 3i is my answer. So remember that really means 6 plus 3i and 6 minus 3i. Okay, one other thing. We always put this number in the front because it just makes it easier to read. So you noticed I did it earlier and I didn't say anything, but you put it in front of the plus or minus. So you wouldn't say plus or minus 3i plus 6. So that's just, you would never see this answer. You're always going to see this in front of the plus or minus. Also with complex numbers, you're always going to see the real part first. So the real part of this number is 6, and the complex part in the imaginary part is 3i. So this is the real part, this is the imaginary part, and together it's called complex. So it's just a little vocabulary for you. Okay, next one. Actually, that's all we're going to do for complex numbers. So you're just going to be, oh, complex conjugates. I'm going to give you another vocabulary word. Complex conjugate. Complex numbers always travel in pairs. So, so negative 9i, its complex conjugate is positive 9i. 4 minus 6i, its complex conjugate is 4 plus 6i. Okay, so the complex conjugate is just the, like this one is minus, so this one is plus. Okay, but that's what a complex conjugate is. They always are traveling in pairs. Okay, last part of this. Okay, is quadratic formula. And I'm guessing this is 5.1.6, I think. Okay, so this is the big guns. Quadratic formula will always work. It is just has a lot of room for error, and so that is why we don't use it all the time. There's just a lot of places to make little mistakes, but it will solve every single quadratic that you want to do ever. Okay, sometimes you can't factor them, sometimes you can't graph them, sometimes b is odd and you don't want to do completing the square. Quadratic formula always works. Sometimes it's just more power than you need. So when we look at the standard equation, ax squared plus bx plus c, we have these a, b, and c. That's what we're going to be using for the quadratic formula. So it is x equals, and there's a little song, opposite b plus or minus the square root of 4ac I messed up the song. Hold on. B squared minus 4ac all over 2a. Okay, so it's like Pop Goes the Weasel. So this is the quadratic formula. So you take the numbers, you plug them in, and you complete the formula, and you have your value for x. Okay, so let's just do one, and we'll go from there. So y equals, and this is going to be, we're going to do number 4 from your homework. Okay, so y equals negative x squared minus 5x plus 6. Okay, so when you're first starting using it, I think it's best to identify a, b, and c. So a is negative 1, right? Because there's nothing, there's no other coefficient, so it's 1, and we have to assign this sign to it. B is negative 5. C is 6. Okay, so now we're going to come over to the formula, and we're going to plug these numbers into the formula. So remember I said opposite b is the first one. Well, b is negative 5. So what's opposite negative 5? Or what's negative negative 5? It's positive 5. Okay, so it's not negative. That's why I said opposite b. It's not negative b, it's opposite b. So whatever b is, you want the opposite of it. Okay, plus or minus the square root of b squared, so that's 25, minus 4ac, so 4 times negative 1 times 6, all over 2a. Okay, now, here's where people start to make mistakes. They start putting things in their calculator, and like right here, this is a negative, this is a negative. Anyway, things can get confusing. I find it best to do one section at a time. So b plus or minus, and then, well, this is easy. We can say negative 2. So now we're going to come in here and do what's underneath the square root. So 25 minus 4 times negative 1 times 6. Okay, so we can do 25 minus 4 times negative 1 times 6. Okay, so what is that? Well, this is negative 24. So 25 minus negative 24 is 49. Okay, because it was minus a negative, so that made it positive. Or you could do 25 and then assign the negative to the 4, so negative 4 times negative 1 times 6, which is positive 24, so plus 24. However you want to do it. You could type it in your calculator exactly how it is right here, but just be careful. Also, you'll notice that I always am going to square this number before I put it in the calculator, and that's because it's going to be positive every time. And if you put negative 5 in your calculator incorrectly, if you just do negative 5 squared, it's going to tell you negative 25. You have to do negative 5 with parentheses to get positive 25. So I just do that one in my head every time. I don't let my calculator do it, because I know that it's always going to be positive. Okay, so now I'm going to simplify. Well, what is the square root of 49? We have an answer for that. 7. So 5 plus or minus 7 over negative 2. Now, I can actually, sometimes I can't find any answer. Like if this was, 47, not 49, then my answer would be 5 plus or minus the square root of 47 over 2. Like that would be done. But this, because 49 has a square root and it's 7, I can keep going. So it's going to be 5 plus 7 over 2 and 5 minus 7 over 2. So this is 12 over 2, which is 6. and negative 2 over 2, which is negative 1. So here are my two answers. Solutions, zeros, roots, x-intercepts. Bam, right there, ready to go. Okay, so that was a really good way to solve that problem. Now, could we have also factored that? Yes, we could. So let's do another one. Last one. Let's just make one up. Okay, so this isn't on the homework. So y equals 4x squared minus 5x plus 6. No, let's 11. Make sure it's weird. Okay, so A is 4, B is negative 5, C is 11. So once again, opposite B plus or minus the square root of B squared minus 4AC all over 2A. Okay, so here we go. Opposite B. So what's opposite of negative 5? 5. Plus or minus the square root of B squared, 25, minus 4 times A times C. Oops. Okay, all over 2A. Okay, so I'm still solving. So 5 plus or minus the square root of, okay, so 20, let's see, 4 times 4 times 11. So 4 times 4 times 11. 4 times 4 is 16, times 11 is 176. So 25 minus 176 is negative 151. Okay, all over 2A, which is 8. Okay, so we have an imaginary number. So we're going to pull out the I. We're going to leave in the 151. That's fine. So 5 plus or minus I root 151 over 8. This is my answer. Okay, and the reason I did this is, like I said, this is the same as the square root of 151 times the square root of negative 1, which negative 1 is the same as I squared, so that is I. So this is the best, most simplified answer. So how many roots does it have? It still has 2 roots. Are they real or are they complex? They are complex. So technically I could write this as 5 plus I root 151 over 8 and 5 minus I root 151 over 8. So there's my 2 solutions, but we say it's easier just to write it like this. So that's what it means. Okay, that was a lot. I don't think you'll have time to watch it twice, but I would maybe even start it back over. Go back and watch one of the sections that y'all still have questions on. I will be there next week, woohoo, to answer any questions you have. And you do have 2 subchapters this week, so you're going to get a lot of good practice. So if you have any questions, let me know, guys. Bye.